Hi guys, welcome back to my channel. I'll be taking you through surface area, right? So in multivariable, to find the surface area of any part of a function over a region is given as the double integral over that region, square root of the partial derivative with respect to x squared, the partial derivative with respect to y squared, plus 1, then the a, okay? So this is a problem. Determine the surface area of the part of z equals xy. So this is a plane that lies in a cylinder given as this. Always, whenever they give you a region in the form of a cylinder, a disc, ellipse, you know you're dealing with what? Polar coordinate, or that will be the only mean. But first of all, we need what? Fx, we need Fy. What is Fx? If you differentiate this with respect to x, so that you get y, with respect to y, you're getting what? X. Is that not it? So our s will have our function in the square root be what? Y squared plus s squared plus 1. Right? Yeah. So with this, we only need our region. But for a region being a cylinder, as I said, we need to convert it to polar coordinates. So we have r and theta. So x squared plus y squared is the same as r squared will be equal to 1. And we having r to be greater than or equal to 0, but less than or equal to 1. Okay. Then you also have our, since it's a cylinder, when you collapse it on the xy plane, it will be a what? Complete circle, right? A complete circle. Sorry, a complete circle. So that will give us a 0 to 2 pi. Okay. So 0 less than or equal to theta, less than or equal to 2 pi. So double integral 0 to 2 pi 0 1 of the function square root of, now x squared y squared become what? R squared plus 1 r d theta. So this is a simple integral, you know. So making substitution, you realize that when you differentiate what is inside, you're getting 2r and you divide it. So you're getting 1 out of 2 outside, 0 to 2 pi of what? Here becomes root of u, okay? Root of u. So let me make it like u, okay, du. If I do that, I have to introduce my, so I wanted it to do it straight away. So let me do it somewhere and introduce it here. So using my substitution, half will come. Realize that you'll be left with what? U to the power what? Half. Okay. When you integrate this, you're gonna have 2 over 3 times the expression r squared plus 1 to the power 3 over 2 from 0 to 1 theta. I'll bring my 2 over 3 out and that will cancel to give me 1 over 3, 0 to 2 pi, and I'll have r squared. When I put 1, 0, when I put 1, I'm going to have what? 2 to the power what? 3 on 2 minus, when I put 0, I'll have what? 1, right? Yes. Then when I integrate with respect to theta, I'm going to have 1